Hello, 7th grade science students. Welcome to your crash course video on geologic time. This video will highlight the major changes in Earth's environment and organisms over billions of years, which we can infer from studying rock layers and fossils. From studying Earth's past, we can make educated inferences for the future. First, we need to gain an appreciation for how old Earth is. Using absolute dating, geologists infer that Earth is approximately 4.6 billion years old. For perspective, in about 6 months, Earth will be 4,600,000,001 years old. Make sure to wish Earth a happy birthday. Give the gift of recycling or planting a tree. To understand how much 1 billion really is, let's say you want a private viewing to a Bronco game. The stadium holds approximately 75,000 people, so you are 1 in 75,000. To be 1 in a billion, you would need to be the only person sitting out of 61,333 Bronco stadiums. Again, this represents 1 in a billion, but Earth is 4.6 billion years old. Our Earth is 4.6 billion years old, but humans as a species are relatively new to the scene. If you think of Earth's timeline as a 24-hour day, we Homo sapiens didn't appear until 30 seconds before midnight. When you study ancient civilizations from hundreds of years ago in social studies, well, from a geologic standpoint, they aren't very ancient at all. All geologic and biologic events during the 4.6 billion years of Earth's existence have been organized into the geologic timescale. An eon is the largest unit of time, which can be split into eras, which can be further divided into smaller units of time that we call periods. Think of it like a year being divided into 12 months, and then within that month, you can split that into 30 or 31 days. This is just time on a much larger scale. Right now, we are in the Quaternary period of the Cenozoic era of the Phanerozoic eon. Back before Earth was habitable is known as Precambrian time, with pre meaning before and Cambrian meaning complex life. The earliest segment of time is referred to as the Hadean eon, which always makes me think of Hades, the king of the underworld. Well, Earth looked a lot like the underworld as it was first forming. A billion years later, oxygen began to appear from stromatolites, groups of photosynthetic organisms. This is our first evidence of life appearing in the Archean eon. Fast forward another billion years, the Proterozoic eon is known for the first multicellular life, with the appearance of simple invertebrates like sea sponges and sea stars. At this point in time, all life is simple and lived in the oceans. After the Proterozoic eon, Earth celebrated its 4th billionth birthday, entering the Phanerozoic eon, more specifically the Paleozoic era. The prefix paleo means ancient, while zoic means animal life. So this period kicks off with an explosion of complex life known as the Cambrian explosion. This explosion of life is attributed to cooler temperatures and more oxygen. So as a result, we have a lot of diverse and complicated life, but it's all in the oceans at this point. The Ordovician period is known for the first land life, specifically of mosses and fungi. This period ends with a cooling climate, which results in an ice age, causing a significant extinction event. Life rebounded during the Silurian period as the climate warmed back up. The fossil record indicates the first appearance of spiders, insects, and vascular plants such as ferns. The Devonian period is known as the age of the fishes, but another significant event is the development of amphibians, organisms who spend the early stages of life in water, but eventually can survive on land. The Devonian period ended because of another significant extinction event. The Carboniferous period is best known for giant insects. Think of dragonflies the size of a large dog. and fossil evidence suggests that the first reptiles evolved too. Geologically, Pangaea had completely formed as well. In the Permian period, we had the Dimetrodon. He's considered a large reptile. We don't have dinosaurs yet. But the Permian period is best known for the Great Dying. Nearly 90% of all living species were wiped out at this time. This is likely due to significant global warming. 10% of organisms that did survive the Great Dying event continued to thrive into the Mesozoic era approximately 250 million years ago. Think of Meso as middle. We're in the middle era of the Phanerozoic eon. This segment of time is also nicknamed the Age of the Reptiles. This era begins with the Triassic period, where we have the first dinosaurs as well as the first mammals. However, due to a sudden increase in carbon dioxide, Earth experienced yet another extinction event. Organisms who survived the Triassic extinction continued to evolve into the Jurassic period. Now, pop culture can be very misleading. There were no T-Rexes during this time period. Hollywood has lied to you. But there were many other species of dinosaurs during this time period. The physical world also went through some significant changes as Pangaea began to separate into the continents we have today. Now, the Cretaceous period of time is when those big beast dinosaurs appeared, but it's also when they disappeared. It's hypothesized that about 66 million years ago, an asteroid collided into Earth, causing the extinction of over 75% of Earth's species. This extinction event marked the end of the Mesozoic era, bringing us into the Cenozoic era, nicknamed the Age of the Mammals. The first period of time can be referred to as the Tertiary period, but other scientists argue this segment of time should be labeled as the Paleogene and the Neogene periods. In this time period, we see the development of species we are familiar with today, hence the prefix Ceno, meaning familiar. In the Paleogene period, we had the first primates and birds, and the Neogene period, hominids, who are ancestors to the modern humans, existed. This period is also when we see the emergence of the most recent ice age. The Quaternary period begins as the climate begins to recover. Notable organisms include the mammoths as well as the saber-toothed tigers, and this time period brings us to where we are at today. There you have it, all 4.6 billion years of Earth's existence in one chart. Note, the X's represent mass extinction events, some causing the end of an era of time. It appears a mass extinction event has occurred roughly every 2 periods of time since the Cambrian explosion. Does this pattern suggest we should be preparing for something? Is Mother Nature preparing us a perfect storm? Or is it human activities that will cause a dramatic shift in our climate that will lead to inhabitable conditions? Only time will tell.